start the recording now. So every photo gets a unique geotag, a latitude and a longitude that again identifies where the photo is taken. So if you come home after a hiking trip with 500 photos, you can easily extract all these geotags from the photos to also kind of reconstruct your hiking routes. And then, of course, the Himalayas is well documented in terms of hiking guides. There are a lot of books, a lot of PDF files around that describe a lot of routes in the Himalayas. But of course, these are all descriptive. They are not accurate. They are not like GPX files, which give the accurate location. They are more like a start from this village, follow the stream, on that turning, take a right, get into that trail going north. So these are more like descriptive, very kind of a little bit more vague and not very accurate. So hiking routes basically, right, are one source of information to plan your hikes. It's in the form of GPX files. Mostly you'll find a lot of GPX files of well-known hiking routes. To have a better view on the Himalayas, you can also look at maps. Okay? Obviously, one map which is available to all of us is like satellite maps. You have Microsoft Bing, you have Google here. So if for example, I go to Sarchu in Lahore, this is somewhere in the middle of the Himalayas on the way from Manali to Leh. Voila, it should be somewhere here. So you can again see as soon as you go in the Himalayas, Google Maps will show you absolutely nothing. It's completely blank. Here you have the Gata loops and the Nakila Pass, the Whiskey Nala towards Leh Manali. Here you actually have the Tsarap River Valley. So completely blank, completely useless. But if we switch, first of all, you have different views here. You can bring up what we call a terrain view. And somehow my map got switched to Marathi, so a little bit difficult to read. Yeah, voila, this is the terrain view. So here you see the same contour lines, which show you already a lot more. You can see all the valleys here clearly. You can see the ridges. You can see the peaks. You can see the mountain ranges. So terrain view in Google does give a pretty good view on the mountains because it clearly shows you the topography, the steepness of the terrain. But again, you don't see any data here. You don't see forests, you don't see trails. If you really want to get more information, you have to go to a satellite view. So here you can see the satellite view. And here actually, if you zoom in a little bit, the beauty about the satellite maps, I would say, is if you zoom in a little bit, let me go to a specific region here. Just a little. A second, I think I'm a little too far. But if you zoom in at a high level here, forget about this Sarap road. This Sarap road doesn't exist. There is no road here in the middle of nowhere. The beauty about Bing or Google satellite maps is if you zoom in at a high level, you will actually see individual trails here on the mountain. Like I think, yeah, no, it's a little bit vague. I think I'm in the wrong area here, but normally you can really see like even 30-centimeter wide trails are visible on the satellite map. Anyway, forget it here. So satellite maps, say, as we already saw, we have been using them extensively. If you come down to the lower Himalayas, here we're a little bit deep inside Lahore and Zanskar. If we go a little bit more towards the green areas, here we're still interior, voila. If you go here to say Chamba Valley, once you start zooming in, the satellite maps will at least clearly show you what we have been looking at for the last couple of weeks, the settlements. And even within the settlements, you will see small trails. You can see the paddy fields, you can see roads, obviously, but you can also see small trails inside connecting village to village. So a satellite map is one very useful map for planning, which I've been using in previous years. However, in addition to satellite maps, also we have a lot of kind of maps which do have a lot of trails. One of the maps, so I've integrated all of these in QGIS, so let me show them from a QGIS point of view. One are the Depi maps. Depi is a guy, Depi Chaudhry, who has been trying to do what we have been doing now. He has been trying, you can see again these 39 Himalayan districts here. He has mapped here, as you can see, pretty much from Kashmir to Uttarakhand, the Himalayas with, this is actually a paper map. So I've just scanned it in, but it's basically nothing more than a fixed scale. You can see it doesn't scale, it's not digital, it doesn't zoom in, zoom out. You can only look at it at a fixed scale here. I think it's 1 by 200,000. So at one scale, you can actually see the trails coming up. And this guy is actually beautifully documented, even not very extensively, just some kind of 40 trails spanning all the way from Uttarakhand to Kashmir. And he has given some important points here, like lakes, Rupkund, some potential campsites he has marked. He has beautifully rendered up, probably with like OpenStreetMap data, forest zones, open zones. He has mapped the rivers. He has given name of the rivers. So beautiful, actually, mapping efforts. A unique effort, I would say. The first of its first of its kind, that has mapped some 50 passes and 40 beautiful routes across the Himalayas. Here you can see the beautiful Leoman Valley, old ancient trade route between Himachal and Tibet. You can also see some of the important peaks have been mapped here. So he has done really a beautiful job, but of course not very useful because as you zoom in, it becomes very grainy. So if I hide all my other maps here, it becomes very grainy. As you zoom out, again, you miss the overview. You really have to zoom in at a certain region to see the trails on that place, right? Voila. So this is like a big paper map actually, which is 17 feet long, displayed in the Indian Mountaineering Foundation office in Delhi, I believe. So it's a pretty accurate mapping job. He has created this map by walking across all these trails, recording all the trails with GPX files again, right? And then basically mapping these GPX files, these hiking routes, on top of standard OpenStreetMap view. Voila. So this is one source, Depi. Another source, which is pretty famous, is the, let me give you the standard OSM background. Another famous, a little bit expensive, and again, mostly available only in paper format, or what we call the Olizane maps. Olizane is mostly mapped the Ladakh here. So if you look again at the districts, this is Leh Ladakh here, this districts in the background. So a little bit of Lahaul and Zanskar, and then mostly Ladakh, has been beautifully mapped in big, these are huge paper maps, like A1 size. This is pretty extensive work. This is a Swiss guy who has mapped Ladakh very extensively with hundreds of passes here. So if you, let me get rid again of this, it's too much of redrawing happening. See, if you zoom in at a certain level, all these, here you can see the bridges, all these passes are marked with Las, typically in Ladakh, the Lahula, Sarmachan La, Bongban La, here another La. They show the altitude. You can see the green zone again, the forest, the cultivated lands. You can see the glaciers which are marked here in blue. You can see the altitude. You can clearly see the contour lines, the topography of the terrain. So these are maps which are extensively used by Europeans. They are not easily available in India. They're quite expensive. I think some 25 euros for one single sheet. But they really, as you can see, right, map the Himalayas, Ladakh extensively. They are, however, in paper map. Paper map basically means, right, that at any given moment, as you walk in this middle of nowhere, that you cannot really accurately know where on the map you are. You will have to look at the reference points, the village names, the shape of the valleys. You will have to look at the peaks actually to kind of try to identify where exactly you are right now on the map. right? So that's the kind of drawback of a paper map versus a digital versus a geo-reference map, which is, here you can see I've basically scanned in these maps and I've geo-referenced them. So which basically puts them in the right place. So if you look at here, Pangong Tso, so I've geo-referenced the map in this place. So if I bring up my base map, OpenStreetMaps, if I hide this map, you'll see that Pangong Tso is mapped exactly in the right place. See? So this is the satellite data, which accurately maps Pangong Tso Lake, and here you can see the Olizane map, exactly the same. If you take any peak here, so if you bring up some peaks, say for example, this peaks here, Kaju Kangri. So if I hide again the Olizane map, voila, you can see exactly the peaks are corresponding to whatever is there on the ground, and even the glaciers here, everything, the ridges, the valleys is all beautifully mapped on these Olizane maps. So Olizane maps are one of the best maps, but again, restrictive in the sense that it only maps the Ladakh part of the vast Indian Himalayas, which is much bigger, obviously, than Ladakh. So if you look at other maps, then next we have the Army maps. You have something called AMS. AMS stands for American Map Service. These are pretty rough maps in the sense that these maps are a little bit grainy. If you look at this, it's a little bit kind of not very clear. But the American Army has also kind of extensively mapped not just the Indian Himalayas, but the entire world from a kind of strategic point of view. And if you look at these black lines here, these are all like trails which have been mapped. And you can see the passes here, Salamu Pass, which goes between Zanskar and Lahore. You can see the district boundaries here between Punjab. I mean, the old Himalayas used to be part of Punjab. These are pretty old maps from the 1920s and 30s sometimes. But at the same time, pretty accurate. What these guys have done manually is pretty much kind of matching what we do now using satellite technology. So if you look at the legend of this map has a lot of detail, roads, trails, jeep tracks. It has, again, forest regions. It has streams. It has all kinds of boundaries. So a lot of kind of useful detail, both natural details as well as geopolitical details have been mapped. And the beauty about these maps is obviously that they have what we call being geo-referenced. The map is clearly basically geo-coded. You can see here the latitude, the vertical numbers, and the longitude, the horizontal numbers of the map. So all the four corners, as well as in irregular distances, they have basically indicated, okay, on the planet, at the top right corner of this map corresponds to 78 degrees longitude east, 33 degrees northern latitude. So this basically allows me to put this map, as you can see, I've placed it here exactly at this latitude, longitude on the landscape. So, and if you just look at, if I hide the map now, you can see that the valley here that you can see, this is Kulu Valley here, Manali, it clearly pretty much matches the reality. If I show the OSM streams, you can see, voila, it's pretty much kind of a little bit like maybe a few hundred meters of differences there, but otherwise this map is pretty much matching the ground reality. Voila, so AMS is nice. Only problem I would say with AMS is the scale. So here, what does the scale mean of a map? Every map, Olizane, Depi, other maps we're gonna look at, they all come at a certain scale. Here it's a scale 1 by 250,000. 1 by 250,000 basically means that one unit, say 1 centimeter on the map, corresponds to a 202.5 lakh times the size on the ground, on the field. So in this case, like 1 centimeter on your map here, if you would use this, here I can of course zoom in, zoom out at any level, but if you use them at the scale that they have been printed, 1 centimeter on the paper map would correspond to 250,000 centimeters on the ground, which basically means 2.5 kilometers. And that is basically a problem. I mean, 1 centimeter on a hiking map corresponds to 2.5 kilometer, basically means two actually large, that's a too large scale to be useful from a hiking point of view. That won't be very accurate actually from a hiking point of view. So if you then look, there are whatever the Americans have done, obviously, during the Cold War, the Soviets have done even at a much better level. They have mapped, again, you can see here, if I show you the entire Western Himalayas, the Soviet, if I enable also the Kashmir Soviet maps. So let me get rid of this, this takes too much time, voila. Most of the Western Himalayas has been mapped by the Soviets at a scale, the scale of the map you see here is 1 by 100,000. This is already much better. The detail, the resolution, you will see at a 1 by 100K map is much better than at a 1 by 250,000. Whatever is not covered by these good detailed Soviet maps, you also have the 200,000 Soviet maps, which covers pretty much the rest of the Himalayas. So if you look at any of these maps, these are pretty nice. I mean, these are like pretty clear here. You can see again a lot of hiking trails. You can see the passes marked here with X's. If I enable the OSM passes, voila, this is the Waru pass. Obviously, the drawback of the Soviet maps is that they are that they are written in Russian. If you look at the trails, so what I've been doing is I've been extracting a lot of these routes. All these green routes are basically taken from the Soviet maps here. So if I hide this map, so after I'm done with this JPEG picture, I basically can nicely extract all the routes from these maps. So after you do that for several maps, you get like a beautiful hiking network, especially the Kashmir and Ladakh area. Has a lot of passes, red passes here, and a lot of hiking trails, beautifully documented in those olds. This would have been mapped in the 70s and 80s when the communist Russia under Stalin has secretly mapped the entire world, actually, including some of these remote places in the Himalayas. If you look at any village here, again, mentioned in Russian, if you bring up, say, like a Bing satellite map, most probably you're going to find like a village here marked, voila, bingo, there you have it. It's just like we have been doing with the survey of India, the same with the Soviet maps, they clearly indicate all these villages, which might also, by the way, be mapped by the NGA here, which we'll look at later on. Beautifully, see how it's meshing. This would have been done by satellite technology, the Americans. NGA is pretty much mapping the old Russian manually created maps, which have been created in the 70s and the 80s. Beautifully mapping. Here we can see Shiraku. Voila, Shiraku, a small village hamlet again, typically in the middle of the Kashmiri forest and mountains. Voila. So this is the Google map now. So beauty about QGIS is that you can show any data, any maps, any trails, combine it all together. You can geo-reference it, geo-code it, and then put it all together in one picture. So very powerful tool. Okay, and then of course, coming to the final maps, the most beautiful, the most accurate maps are our, what is it here? The Survey of India maps. Those of course are more towards the, let me get rid of the roots again. If I select all the maps here, which we have been downloading from the survey online, voila. Here you have the pretty much the whole of Uttarakhand nicely mapped at a still higher detail. So these maps are the best maps in the sense, if you look at their scale, they are at a scale of 1 by. The scale normally is mentioned here. Of course, they are a little bit overlapping, so I'm not sure if it's visible. Voila, here the scale is at, I think it's overlapped by the next map tile. Voila, this is at a scale of 1 by 50,000 here. So this basically means that every centimeter on my map here corresponds to 500 meters on the ground reality. Voila. And here again, you can see, right, the kind of details you find here, the kind of extensive mapping. If you have been looking at this map for a while now, this is unmatched. If you look at an American map, American survey map on 1/250,000, which is 1/5 times the resolution, that will be much more rougher, much more less accurate than the trail, the village, any stream, any peak, pass details, district boundaries you find on these maps will be much more accurately mapped. You can see it again, the maps have been marked with latitude and longitude. Okay, so marking this corner, I can clearly put this map in the right place on planet Earth. I can say this corner corresponds to 78 degrees, 30 minutes eastern longitude and 30 degrees north latitude. And then any mapping tool like QGIS will put it on the right place in the planet. Voila. So if we now put all these maps together, so if it's a little bit slow here, this is like gigabytes and gigabytes of data. If I again look at the entire Western Himalayas, so we got Uttarakhand covered by Survey of India. We got Ladakh nicely covered by, Olizane. And then we have the Soviet maps, which nicely cover pretty much the rest, including here the Soviet 200,000 maps, cover most of Kashmir. Voila. So you can see all of these maps, all of these different map sources all together beautifully cover the entire Himalayas and allow us, say, to extract a lot of useful details like settlements, like rivers, like peaks, like glaciers, like streams, like villages, and like trails, obviously. Okay. So in addition to that, you also have some maps, then touristic maps, like say, for example, you have the Great Himalayan National Park here, which is located right off Kulu Valley. So this is more like a touristic map, not very accurate, but any map becomes useful as long as it carries these latitudes and longitudes on the map. I'll have to restart the session again in 10 minutes. As long as you have the latitude and the longitude, you can actually fix what they call geo-reference these maps and put them in the right spot. And if you look at the routes, which I've been tracing from other sources, you'll see that the routes here are beautifully matched. Like the green routes here from the Russian maps are kind of plus minus matching all these trails that are marked here. Here you can see a yellow trail marked from the Survey of India. It's almost perfectly matching the trails marked on this touristic map by the Himachal Tourism Office to just document one specific valley here. So like that, actually, you can find quite a few touristic maps also of Uttarakhand on the internet. You can geo-reference them. And then you can pick all these villages, all these trails which are marked on them. You can trace them using tools like QGIS to basically extract, digitize them. And once you digitize them, then basically, right, you have all the data in your hands. If you now look at, we have already some 4,000 routes marked right now. So I've marked digitized so many routes from the Survey of India, from the Soviet maps, from the Olizane maps, from the Soviets, some of the American maps, some from the blogs, GPX files, some from the Kulu touristic maps. 300 hiking routes here have been extracted from OpenStreetMaps. These are some Uttarakhand touristic maps. So if you look at all this together, you can see hundreds and hundreds. This is, I think, close to 4,000 hiking trails now. Yellow Survey of India, green Soviet, and red covering Ladakh, Lahore, Zanskar, Olizane. So you can see we have pretty much beautiful coverage now taken from different map sources, right? So if you look at Ladakh here again, this is nothing more than a trail which has been digitized from one of these maps here. Voila. So if you look at the red ones, voila. So the red one is actually nothing else than whatever that black dotted line that was there on a paper map, which was kind of difficult to understand where is it exactly. So after you geo-reference it, you kind of fix it, you identify it uniquely within the geographic space. You can download it in your phone, and then as you navigate to say the Ich2 La Pass here, you can pinpoint your location accurately along this route on the way from Chasu, the last village, to the Ihula, the pass on top there. You can see some glaciers here also. Having digitizing this information rather than looking at it on a paper map gives you a lot of valuable details, basically. I mean, powerful details for digital hiking, digital navigation in the mountains. Okay, so that's about it for the maps. In addition to the maps, as we all know, we also have other sources of information. Obviously, one useful source of information, as we already said, is OpenStreetMaps. So just like you're looking at OpenStreetMaps through one of the viewers here, looking at one piece at a time, you can also look at OSM, download one section at a time. It's actually much easier to look, query OSM data in bulk. So here I have a plugin in QGIS. This is QGIS here. I have a plugin that allows me to query OSM data. It's called Quick OSM. So here I can query anything. I can say place equal to, say, isolated dwelling in, say, the canvas. In the canvas means in my view. I can run this query, and this basically is going to use an OSM API to extract all the place equal to isolated dwellings located in my screen. Voila. Here you can see all the isolated dwellings. Obviously, Uttarakhand has been mapped extensively. Voila. So here you now can see all these things that we have been mapping so far. You can then render this in any way. You can mark it as an assemble. You can put a label here equal to the name. Voila. These are all the names basically which we have been extracting from those same maps over here. Voila. Voila. Here you can see the same stuff, right? So again, instead of just putting it on a paper map, we're kind of viewing it here. We have digitally extracted it's here. So now we can take it from OSM. We can look at it in an OSM viewer. We can download the villages. We can use it in any mapping application like QGIS, in any OpenStreetMap viewer, in any mobile navigation application, which is so much more powerful. Voila. So like that, basically, if you put all the OSM data together, it becomes quite impressive, right? So let me get rid of this. Where is the remove? Voila. Okay, so obviously you already saw we have the passes. Passes are extremely important because they give you gateways. They give you ways to go from one valley to another valley through the mountains. High altitude alpine lakes are beautiful, and you all know like the Moondal Lake. You have Chandratal Lake, Somiori, Pangongso. These are all like beautiful hiking destinations. You have the peaks. Peaks will be very useful for mountaineers more. You have then the places which we have been mapping. So if you look at, you have here the localities. These are like deserted human settlements. You have the isolated dwellings, which we have been mapping, which are basically like small isolated settlements. We have the hamlets, which we have been mapping, then the villages, then we have the towns, the bigger towns, and then we also have the temples here. Temples are typically like pilgrim destinations. So just like passes and lakes, temples are very useful because they mostly have beautiful trails to them. And then, of course, for the hiker, you have the alpine guests, the guest houses, the wilderness huts, and a couple of other things which I haven't queried here, but you have campsites, which are quite extensively mapped, all useful. You have the waterway, river waterway, stream, pretty much useful. Well, so OSM basically gives you a lot of useful information that you can query through QGIS, you can combine it with other information. As I mentioned, you also have this NGA database. So these are the 40,000 human settlements across the Himalayas. So I think there were some millions of these across India. So with QGIS, it's beautiful. You can then truncate all the data you need. You can kind of only take the villages which are part of these districts. So I can run all kinds of mathematical processing on QGIS, extracting only the data of my place of interest. If you look at this here, it's quite vast, huge. Of course, we don't have to map the lower Himalayas. I think we can just focus on mapping all these villages in the interior regions of the Himalayas. Voila, that is there. And then you also have other useful databases of geocoded data. So in addition to NGA, you have the Japanese Alpine Club. You have the Indian Mountaineering Foundation, which have extensive databases on peaks, on passes, on lakes and stuff, which you can then in applications like QGIS, you can put it all together with your GPX files, with your maps, and basically creates like a master database or a master map of the Himalayas. Okay, so after you have all this data basically coded here, after you have all these routes and villages and all that stuff, you can do all kinds of interesting processing in a tool like QGIS. So let's maybe do a couple of things. So I mean, one other important thing that we have to be aware of is, so all the stuff you see mapped here basically is geocoded with latitude, longitude. So we have basically kind of mapped all these places in 2 dimensions. So if you look at Satok here, Satok, if I go with my mouse to this place, if you look at the bottom of the screen here, you'll see the coordinates. You'll see the exact latitude and longitude. So here we see 77.40 degrees eastern longitude and 33.194 northern latitude. So that will be the unique 2-dimensional location of the isolated dwelling Satok along the Tsarap River here. In this case,